Hello and welcome to the Falcon Tech Solutions Central video blog. This video blog will be focused on the steps necessary to walk through creating a pipeline with a copy activity using Data Factory Editor. We will create an Azure Data Factory. In this step, we will create the Azure Data Factory. We'll use the next step to create link services. We will create two link services, one for a storage link service and one for a SQL link service. The storage link service links to the Azure Storage, and the SQL link service links to our Azure SQL database. The input data for the pipeline resides in the blob storage, in the Azure blob storage, and output data will be stored in a table in the Azure SQL database. Therefore, you add these two data stores as link services to the Data Factory. In the previous step, which was the link services step, we created link services that refer to data stores that contain input and output data. In this step, you will define two Data Factory tables, one from the blob and one for the SQL table, that represent input and output data that is stored in the data stores. For the table from blob, you will specify that a blob container that contains a blob with the source data, and for the SQL table, you will specify the SQL table that will store the output data. You will also specify other properties such as structure of the data, availability of the data, etc. When we create a pipeline, the pipeline will have a copy activity that copies the input data from the Azure blob to the output Azure SQL table. The copy activity performs the data movement in Azure Data Factory, and the activity is powered by a globally available service that can copy data between the various data stores in a secure, reliable, and scalable way. Lastly, we will monitor the pipeline, and in this step, you will monitor slices of input and output tables by using the Azure Portal. So our first step is to create the Data Factory. Again, in this step, you'll use the Azure Portal to create an Azure Data Factory, and we will use our Falcon Tech naming standard that we've been using throughout the other prerequisite videos. So the first step you have to do is actually make sure that you're logged into the Azure Portal, and from here, we actually click New, Data Analytics, and then we just scroll down just slightly, and then we select Data Factory. Now that we are in the new Data Factory blade, we want to enter a name for our Data Factory. And in this case, I want to use, and this will actually go out and do a check, Falcon Tech Data Factory. It will now go out and do a check to see if that name is actually available. In this case, it is. Again, it's going to tie to the subscription. In this case, I only have a single subscription. It is now going to go and ask me to now enter the resource group name that we want to create or use in this situation. I did create a previous one, so you do have the option to go out and look at existing ones, or you can create a new one from this point. I'm actually going to go out and try to find one of the ones that we created previously. If you have done the prerequisite videos, you will recognize that our Falcon Tech resource group is now available. This is the one I want to select in this case. I'm going to leave the region name as West US. So now that I have these pieces of information, I will simply click Create, and it will now go through and start the process of creating that Data Factory. One key thing to note is that the name of the Azure Data Factory must be globally unique. If you receive an error, the Data Factory name, for example, is not available, you should change the name of the Data Factory. So for example, if I went out and tried to recreate the Falcon Tech Data Factory again, I would get an error message saying that I can't use that one because that name is no longer globally unique. So in our notifications hub, we've looked at the notifications, and we see that everything appears to be good, and after the creation is complete, you'll see a Data Factory blade shown below. So in this case, I should be seeing a Falcon Tech Data Factory blade, or in this case, I could actually maybe go out and look or browse for it. But Since I don't see this, I believe I'm just going to go ahead and look for it and do the browse. And there is our Falcon Tech Data Factory. So I'm actually going to click the name of this data factory, and it will now load the data factory blade. And in here, I'm going to be able to do several things. The first thing that we want to do is we want to create a link service for the Azure storage account. So in the data factory blade, I want to click the author and deploy tile to launch the editor. So next, we will, in the editor, click the new data store button on the toolbar and select Azure Storage from the drop-down menu. And you should see a JSON template that appears here on the right-hand side. And this is for creating an Azure Storage link service right here in this right pane. Two key pieces of information that we have to have for this to work here is that you have to replace, you'll need to replace the account name and account key with the account name and account key values for your Azure Storage account. In my previous prerequisite tutorials, my blob storage account name is Falcon Tech Blob Storage 1. So I will place that here. The account key, this is the keys that are stored or associated with my Azure Blob Storage. You can use either key 1 or key 2, and you will place that right here. So to finish this step, we simply click Deploy on the toolbar, and this will actually deploy the Azure Link service that we're creating. We will definitely want to make sure that we get this message where the link service was deployed successfully. Now the next step, we want to create our link service for the Azure SQL database. So to create a link service for the Azure SQL database, we'll take the same steps that we did before. We'll do new data store. Now we want to do this for our Azure SQL database, so we want to select Azure SQL, and in this JSON script we have several values that we have to replace. The values that we will be replacing are all in our connection string. We will be replacing the server name. This is our SQL server name that we created in our prerequisite steps. The catalog, this is our database name that we created, so we have to replace that. Then we have to also use and replace the username at server name, so we have to create that combination. And lastly, we have to enter the password that's associated with this username. So the name of our SQL server that we created in our previous steps is Falcon Tech SQL Server, so it's plugged in there. The database I created in our prerequisite steps, the name of it was Falcon Tech DB, and I replaced this here. I have entered my username and password. I've obfuscated it obviously to protect the security of the SQL server, but the key things here are to remember your username that you're using to log in to your Azure SQL Server instance and this password that's associated with that. This was in the prerequisite steps where we created the Azure SQL Database server instance and then also the SQL database. To complete this step, we click Deploy again, once again, and we want to wait to make sure that that link service was deployed successfully, and by this indication we are. So in this step, previous step, we created two link services. One was for the storage link service, and the other one was for the Azure SQL link service. And to link an Azure storage account and an Azure SQL database to the data factory. That was basically what we covered previously. In this next step, we want to define two data factory tables. One will be called imp table from blob, and the other will be imp SQL table, that represent the input and output data that is stored in the data stores referred by the Azure Link Storage Link Service and the Azure SQL Link Service respectively. So for the imp table blob, you will specify the blob container that contains a blob with the source data, and for the SQL table or imp SQL table, we will specify the SQL table that will store the output data. So the first thing we want to do is create our input data set. And essentially a table is a rectangular data set and has a schema. In this step, we will create a table named imp blob table that points to a blob container in the Azure stored represented by the Azure Storage Link Service that we created previously. So in the editor here, for the data factory, we want to click New Data Set, and I want to click Azure Table. And what we'll do is we have a JSON script that we want to replace the default, and we will now put that JSON script in here. And this is the step we just performed here. We've replaced the template JSON by the JSON that's going to now define the blob table that we're creating. A couple of key things to note here is the first thing I want to bring to your attention is the dataset type is set to Azure Blob. The link service name property setting is set to Azure Storage Link Service, which is what we created in our link services step. The folder path is actually set to the container. If you remember in our previous prerequisite tutorial, when we set up our container, we named our container Falcon Tech Container. So what I'm going to place this right here is actually type that in right here. Our format type is text format, and there are two fields in the text file, which is first name and last name, and it is separated by a comma or a column delimiter of a comma. The availability is set at a frequency of an hour, and the interval is set to 1. This will allow the data factory service will look for input data every hour in the root folder in the blob container of Falcon Tech Container. So if I had multiple employee files, for example, that were coming in and trickling in throughout the day, every hour this service would go out, check to see if it had any new files in the container, and load those files through the Azure Data Factory link services with the input data set that we've created, and ultimately loading that to my SQL table that's now in the Azure SQL database. Also, one thing to note here is if you do not specify a file, which if we went to our blob container, we will actually see that same file is setting here, imp.txt. However, if I did not provide a name or specify a file name for that output table, the generated files in the folder path are named in the following format, or all the files that would come in are scheduled or considered as input files, so they would just automatically pick those up. The point is if you don't specify a file name for an input table, in this case, if I didn't specify one there, all files and blobs from the input folder path are considered as inputs. So if you specify the file name in JSON, only the specified file blob is considered as an input. So now we will click our deploy button, and we will wait to see if we get our imp table from blob created successfully. So we will now do that. The table has now been deployed successfully. And now we need to move on to creating the output data set. So in the create output data set, we want to create an output table named imp SQL table that points to a SQL table in the Azure SQL database that is represented by the Azure SQL Link Service link service. So in this editor, we want to get started. We want to click New Dataset. I want to pick Azure SQL. I am going to replace the template JSON with JSON that I've previously written. So again, a couple things to note. My dataset type is Azure SQL Table. My link service name is Azure SQL Link Service. That's one we created previously. My table name is IMP, so I want to make sure that that is still true. So I'm going to come out to Management Studio, real quickly show you this. So in Management Studio, I'm connected to my Falcon Tech SQL Server in the Azure SQL database. I've got my Falcon Tech database, and in my Falcon Tech database, I have a table named IMP. The availability is set to an hour, and the frequency interval is set to 1. Again, the Data Factory service will generate an output data slice every hour in the IMP table in the Azure SQL database. So with all this being set, we simply click Deploy. We should be able to see that we've done things successfully here, which brings us to now the next step, which will be creating a pipeline. So in this step, we want to create a pipeline with a copy activity that will use the IMP table from blob, which is pointing from our blob storage in the container as input, and the SQL table as the output. So in the editor here for the Data Factory, we want to click New Pipeline. So you'll say, okay, I don't see the new pipeline. There's this ellipsis tile right here. If I click more, I now see more options available to me. The new pipeline is all here available. I can also right click on this and ask for a new pipeline. Either way will get you there. For now, we'll just click our new pipeline tile. So now we have our JSON editor. This is just by default what is displayed in here. I am actually going to replace this with an existing JSON script. So again, a few things to note here in the JSON. We're creating an ADF tutorial pipeline. This is the name of the pipeline we're creating. And I want you to notice that the type is a copy, which means that it's set to a copy activity. The input for the activity is sent to IMP table from blob, and the output for the activity is set to IMP SQL table. In the transformation sequence here or section, I want to show that this one is set to blob source as the source type, and SQL sync is set as the type specified for the sync type. So the next thing we want to really focus on is now setting our start and end times or dates specifically. So since I am now at April 15th, 2016, and this date format is basically where I'm going to replace those values or start the property value with the current day and the end value with the next day. So in this case, I'm actually going to set this value to 2016 4/15, and my end date value will be set to 2016 4/16. So both start and end date times must be in ISO format. So as we see here, this is an ISO formatted date in both the start and the end. In my case, I am going to use the current date, which as you can see here in my date and time clock area, it is about 11 o'clock in the evening, and I'm April 15th, and I'm actually going to now also set that to the next following day. So in this example, the way we have this set, there will be 24 data slices as each data slice is produced hourly. So in order to complete this step, I simply click Deploy, and I want to make sure that I get a successful message here, and it appeared quickly. So now we want to close the editor blade by just clicking X, and I want to click X again to close this Falcon Tech Data Factory blade. And now I should be back to the Data Factory blade for, in this case, the Falcon Tech Data Factory. So we've made it back this far, so we have successfully created an Azure Data Factory, link services, tables, and a pipeline, and scheduled the pipeline. So really the next steps in this is to view the data factory in a diagram view. To do this, I'm in this data factory blade, my Falcon Tech data factory blade. I want to now click diagram, and this will actually show a diagram of what we created. So now I want to potentially take a look at what's in that pipeline. So if I click my pipeline, I right click and say open pipeline, it is now telling me what my activity is, and it's copying from the blob to SQL, and it's indicating that it is a copy activity. And what this is telling us is that this is a copy activity with the imp table blob as the input data set and the imp SQL table as the output data set. And to get back to that original view, I just click this breadcrumb and it'll bring me back to where I was originally. In the following step, we want to use the Azure Portal to monitor what's going on in our Azure Data Factory. You could also use PowerShell commandlets to monitor data sets and pipelines. There is information out on Azure how to do this, but in this case, we're going to use the Azure Portal to work with monitoring the pipeline. So we are now back at our Falcon Tech Data Factory blade. And if everything's going okay, we should see, we've got 2 data sets. So far, we don't have anything with errors. We see that we have a pipeline that is scheduled, and we actually have 2 data stores, which is our blob and our SQL store. So if I click this datasets tile and I click my imp table from blob, this is the input table for our tutorial here. And what we're starting to see is that this data is ready. It's queuing it up and saying, hey, it's ready to go. And you'll notice that everything up to our current time, and we're now hitting 11 p.m. So 12 a.m. we're starting to add these data sets. We'll start seeing these pop up over time, and it's going to try to continue to add them as we go. And the reason this is doing is because that imp.txt file is continuously present all the time in our blob container, which was our Falcon Tech container that we created or we saw in our Cloudberry tool here. So I go up one. Our Falcon Tech container, we have a single file in our container. So if you notice, we have the recently updated slices, and if we had any failed slices, they would appear down here as failed slices. You would see that they have a red indication indicating a failure of some type. I can also click on the ellipsis button here if I want to see a larger list of slices. I don't necessarily have any additional ones, but if there were more, I click this ellipsis and it would take me now to the full list. We now see that I now have a full list that are queued up all the way up until about 6 a.m., 7 a.m., 9 a.m., 10 a.m. So 24-hour period tomorrow at some time. So I'm talking to our future state here that we've actually got our input files from our blob storage basically already queued up and ready to go to begin processing. So I'm actually going to come out of this blade, click out of that blade, click out of this guy, and then I want to go to my imp SQL table, and this will actually start telling you, hey, I've got some files in progress already getting loaded. We also have some that are pending execution. And what it's trying to do, because we're past these times in the day here, as you did see, we did set our date to start as April 15th, 2016, and our end date as April 16th, 2016. And what it's trying to do is make an attempt to now catch up. And so we see some that are ready and queued up, some that are pending execution, and some that are already ready and in progress. So we're in progress of loading our SQL table with our employee data. So far, we don't see anything that's queued up as a failed. If it did, we would have to investigate from there what might be the case or what might be the problem. Again, by clicking the ellipsis, I have a full list of files already, or not the files, but the data being loaded to my SQL Server or Azure SQL database. If I click on any data slices, we click on this one right here that's showing in progress, it's saying, hey, it started, it's running. Right now it's still updating the slices and they're not necessarily ready, and it's running. It may refresh as we run here, but as it's updating, it shows, hey, I got started at 7 p.m. or I'm trying to catch up here. The status is in progress, and we would have to wait for that to potentially update or refresh to see when this actually updates. Here we have one that looks like it's completed, so we had a start time of 6:08, and it tried to finish that up. It's saying that it succeeded. It's looking for any errors or seeing what we actually used. So we read in 22 bytes and it wrote out 32 bytes, and it wrote 2 rows. The 2 rows for employee data, the Jane Doe and John Doe records. To verify if we have that, so if I run my query in SQL Server Management Studio against my Falcon Tech DB and on the imp table, we can see that we actually have 12 records loaded currently. And as the records load and those slices process, we will see more records loaded here. At the completion of this, we should see 48 records loaded. If all slices are successful, and we will come back to that and review that to see if that remains true. But we have these queued up, some of them in process. So far this guy is looking like it's still trying to figure out and run. So in this tutorial, we created an Azure Data Factory to copy data from an Azure blob to an Azure SQL database. We used the Azure Portal to create the data factory, link services, tables, and a pipeline. And the high-level steps we performed in this tutorial were to create an Azure Data Factory, create link services that link data stores and computes, referenced as linked services to the data factory, create tables which describe input data and output data for the pipelines, and then create pipelines. A pipeline consists of one or more activities and processes the inputs and produces outputs. We set the active period for the pipeline by specifying a start time and end time for the pipeline, and the active period defines the time duration in which data slices will be produced. Thank you for watching this Falcon Tech Solutions Central video blog on how to create an Azure Data Factory. Have a great day.